Okay, welcome back everyone. So I'm going to give you the answer, lift the magic about this problem here, give you the answer. What's the starting material? It is a cyclic compound, which of course has a double bond in it. So when we do the ozonolysis, you cut the double bond, right, and then gives you the product. One great way to check whether things work out as you plan them is to number, again, the carbon chain. In this case, we are not numbering it according to how we name it, right? We just want to see where the carbons are to map the starting material of the product. So you can sort of number anywhere you want. In this case, we start on the methyl group. And then we see we have 1, 2, 3, 4, 5, 6, 7 carbons, okay, in total. And so we need to put a carbonyl group, like the CO double bond, onto carbon 2 and onto carbon 7, right, where the double bond was. And now you can number the product. You see how it works out. So you have 1, 2, 3, 4, 5, 6, 7. And you see we put the CO double bond, I have put it on 2 and on 7. Carbons 2 and 7. That's how you can check yourself, okay, by numbering the carbons. So you don't draw extra carbons or too few carbons. A very common mistake. So now I would like to summarize. What do you do? How do you, when I give you problems like this, how do you go about doing these in a strategic manner? What do you want to do, particularly for these addition reactions? And it also applies to kind of SN1, SN2 reaction. I've given you a similar guide there, right? How do you do it? Number one, you need to analyze all the reagents, right, and determine what the reagents will do. So some reagent memorization, a little bit of reagent memorization there is helpful for sure. And you want to know what they do and what will be added across the double bond. Okay. Now number two is you want to determine the regioselectivity of that reaction. Right? Once you recognize the reagents, you should know what's the regioselectivity, and that means is the reaction going to go in a Markovnikov fashion, where the nucleophilic part of the reagent then adds to the more substituted carbon atom in the end of the double bond in the end, or is it going to be anti-Markovnikov, right? That's what you need to know. And then number three, so you need to worry about stereospecificity. So you need to know whether it's, in particular, whether it's a syn addition or an anti-addition, right? Syn again meaning both groups which you're adding to the double bond come from the same side. Anti means they're coming from opposite sides. And then lastly, you need to worry about, whether you're forming enantiomers or not, whether the compound you're forming is a meso or not, chiral or not. Okay, so in general, what I recommend you to do in terms of studying more for the final is you need to do some minor reagent memorization. Okay, so some of these reagents you just have to know. For example, you need to know that we are using a palladium or platinum and carbon catalyst and hydrogen to do hydrogenations, right? That's just, you have to know that. And so making some flashcards with these reagents is helpful. But then it is absolutely crucial to really grasp the mechanisms of how these reactions happen, except the ones I specifically told you, for the ones which you don't have to know the mechanisms for, these complex steps. For example, for the ozonolysis, there you just remember the reagent and what it does. But for the other ones where we drew the mechanism out, you have to know the mechanism. Okay? Very important. You have to be very... And you see, why is it important? Because mechanisms are always the same, very similar. And that really will help you memorize as well what's going on. All right? So, in general, the more familiar you are with these mechanisms and how they all fit together, the easier it will become for you to predict products of reactions. So I would like you to practice with Skill Builder 8.9. That's what we should be doing. I'll give you a couple seconds to write this all down. Okay, so this is Skill Builder 8.9. It's really what we're talking about here. course, practice is key to recognizing these reactions and applying them. So now what we're going to do for the end is do some synthesis practice. Okay, we're just going to literally apply these reactions, and I want to see how well you can put all these things together. I'm going to give you a couple of reactions to start with. We do set of 3 and then another 2 after. So here I'm just gonna, this is relatively simple, so I'm just gonna do a one-step thing. So here I give you the starting material and the product, right? And I want you to figure out what the reagents are, the question mark. For the second reaction, starting with an olefin, and I want you to figure out the reagents. And they can be, these reagents here can be multiple steps. It can be 1 or 2. 1, 2 sometimes. For example, if you're doing epoxide formation, then opening of the epoxide, that would be 2. That would be 2 reagents, right? And then here another one where we're going from the epoxide and we're using H plus and methanol, and I'd like you to figure out what's the product, okay? So these things can go in different ways. I can either ask for the starting material, the reagent, or the product, and then those are the easy questions. The harder ones we're going to look at next going to be where I'm giving you multiple things in between to figure out. Okay, I just give you starting material and then a product, but you have to do like 3 or 4 steps in between. That's where it becomes much more difficult then. All right, so try this out. Take about 5 minutes or so to try to figure out these reactions. Then we're going to reconvene and I'm going to show you how to do it. Thank you.